A lot of Azure Virtual Desktop or AVD environments don't fail on day one. Okay, they're built correctly, users can log in, everything looks fine. And over time, you start to see the real issues. Performance complaints, inconsistent user experience, rising costs, and an environment that becomes harder to manage the longer it runs. The reasons for that is not usually a bad deployment. It is bad design decisions made early that don't scale properly. Again, it's quite clear from Microsoft documentation that while it manages the AVD control plane, customers are responsible for the configuration of session hosts, identity, applications, and the operational behavior. So if your design is weak, those weaknesses are going to show up in production very, very quickly. In this video, I'm going to break down the most common AVD design mistakes I see, why they happen, how they impact performance, cost, and stability, and what you should be doing instead. AVD is often described as managed VDI service, and that is true in the sense that Microsoft runs that control plane component like the gateway and the connection service. But they also make it very clear that in its security and architecture guidance that customers still own the configuration and the operation of the infrastructure that delivers those desktops. And again, we've mentioned some of these in previous videos. That includes session hosts, identity integration, storage, and networking design. That's a shared responsibility model, right? And it's critical because it means AVD is not opinionated enough to save you from bad design decisions. You get flexibility, but that flexibility is exactly what creates inconsistent outcomes between environments. So the goal of this video is not just to point out what goes wrong. Okay, everyone can do that. Anyone can criticize. But I want to show you how those design choices connect directly to behavior you see later in production. The first major issue is designing the environment only for initial deployment, not for long-term operation. A lot of AVD environments are sized based on sort of user count at the time of deployment, assumed workload patterns, and best guesses about performance. But again, the official sort of Microsoft documentation that they give you, cost and scaling guidance highlights especially and specifically, and it says that AVD is built on Azure resource consumption. What this means is that sort of behavior changes over time, essentially, right? Usage patterns shift, applications change, and user load fluctuates in the environment. If it's not designed with that sort of variability in mind, it becomes either over-provisioned, this is where too many resources run continuously, or under-provisioned, right, where performance suffers under real usage. What I want to try and explain is, right, that again, Microsoft say this to us, and it explicitly provides autoscale as a mechanism to deal with its sort of dynamic behavior. This allows session hosts to scale up and down based on demand. That alone tells you that the platform expects variation, and your design should reflect that from the beginning. So the mistake is not just poor sizing. The mistake is assuming the environment will stay static. The second issue is how session hosts are actually designed and used. Again, the official documentation does make it very clear that session hosts are sort of standard AVD machines and they follow the same compute costs and performance model as standard Azure VMs. That means performance and costs are directly tied to how those VMs are sized, how they're configured, and how they're utilized, right? And there are three major design mistakes here. The first one is oversizing VMs, okay, because teams often choose larger VMs than required, and this is to avoid those sort of performance complaints, right? It's too easy to do that. This increases cost significantly without really improving the actual user experience when workloads are not using the available resources. Second is underestimating session density, right? In pool host pools, the number of users per VM is one of the most important design factors. Okay, autoscale prerequisites state that you need to configure the max session limit. We've mentioned that in a couple of other videos, right? This is a very important parameter. Not only don't rely on those defaults. That's a strong indication, again, that session density should be an intentional design decision, not an afterthought. The third is the inefficient load distribution, right? If users are spread across too many hosts instead of becoming consolidated effectively, you end up running more VMs than necessary. This increases cost without delivering additional value. The key takeaway here is that session host design is not just about performance. It's about the foundation of both cost efficiency and scaling behavior. One of the most common mistakes I see is environments that technically have autoscale configured, but the design behind it is totally incomplete, right? Autoscale allows session hosts to scale based on schedules and capacity thresholds, using defined phases such as ramp up, peak, ramp down, and off-peak periods. But just turning autoscale on does not mean it's working correctly, okay? There are specific requirements, and we need to you need to understand this before, just just turning them on, right? The scaling plan must be in the same region, first of all, as the host pool, right? The correct RBAC roles must be assigned so the service can actually control VM power states. Very important. The configuration must include realistic thresholds and capacity targets. And you need to avoid mixing autoscale with other automation methods for the same host pool. Okay, these are minimum and really quite simple to do. Where environments go wrong is schedules do not match actual business hours. Ramp up happens too late, causing login delays. Hosts stay online too long after demand drops as well. And then we have session limits, right? They're not actually aligned to real usage. Again, a lot of the documentation that you see from Microsoft, it also highlights that autoscaling is designed to optimize deployment costs by adjusting capacity to demand. That only works if demand is properly understood and reflected in the configuration, right? So the mistake here, again, making assumptions, right? You know what they say about assumptions? They make an ass out of you and me, right? The assumption is autoscaling is a feature you just enable. It's not. It's actually a system you design. If you're working with AVD or Azure and want more of this type, content, real design, not just setup guides, make sure to hit that subscribe button. Everything I'm covering here is based on how these environments behave in production, not just how to deploy. A major mistake is underestimating the role of user profiles in the overall design, right? There's a strong recommendation about using FSLogix profile containers for AVD, right? If you worked with AVD, you know that. These containers store the entire user profile, in the VHD or VHDX files. This is just attached.logon, and it provides a consistent user experience across those session hosts. That architecture is critical for pooled environments especially, but it introduces design considerations that are often overlooked. First, storage platform selection. The recommendation, as I've mentioned in a few of my videos, is Azure Files or Azure NetApp Files. And this shows that storage performance and scalability are very important. Choosing the wrong storage option can lead to slow logons and unnecessary costs. Okay. Second is profile lifecycle management. Right, profile containers grow over time. Anyone in the old RDS days knows that. Users interact with applications, and that's what causes it. Without proper governance, this can lead to larger storage consumption, operational complexity. Third is the configuration sort of consistency. The recommended settings for profile containers is to ensure proper behavior, including managing local profiles and improving container directory handling. So the mistake is not using FSLogix, it is using it without designing around how it behaves at scale. Another issue is overcomplicating identity and support infrastructure, right? The documentation we see from Microsoft shows that identity provider choices directly affect the underlying infrastructure cost. Again, I mentioned it before in other videos, if you use Entra ID with domain services, Active Directory domain services, you introduce additional VM, storage and networking costs for the domain controllers, right? At the same time, the security guidance that we see explains that customers are responsible for securing access to AVD, the whole environment. And you can use controls such as MFA, conditional access and policy enforcement. The problem is when environments actually carry legacy identity dependencies or maybe unnecessary infrastructure or even duplicated services that don't actually add any value. This has a knock-on effect, right? Because it actually increases cost, complexity, and operational overhead. Look, the key is not to remove necessary components, right? We're not trying to do that. But let's try and ensure every dependency exists for an actual reason. Right, we're almost coming to the end of my recommendations here. A final common mistake is treating security and operational controls as something to add later. Again, there's a lot of guidance that highlights the shared responsibility model. We've spoken about that. Okay, we should know what that is by now. Microsoft secures the platform, but customers must secure all those components like session hosts, right? The user access we know about, application behavior as well, and the data protection. Okay. The recommended practice just kind of include, enforcing MFA, as I mentioned, like multi-factor authentication, applying conditional access, right? And obviously, it's really important is maintaining patching as well, not to mention the endpoint protection, right? And then we need to monitor activity through logs, and Azure monitoring tools are great for this as well, okay? If these are not actually built into the initial design, if they're an afterthought, they're very much harder to retrofit later, and the environment becomes harder to secure and manage over time. So the mistake is not ignoring security per se, it is treating it as a separate phase instead of part of the design. Listen, if you take one thing away from this video, it should be this. Most AVD problems are not deployment issues, they are design issues, right? It's coming from an architect, okay? The most common design mistakes are designing for a static environment instead of a dynamic usage. Also, poorly structured session note design and density. I've mentioned autoscaling as well. It needs to be configured, but it's always configured, but it's not aligned to actual real demand. Don't ignore FSLogix behavior at scale either, okay? And let's not forget, carrying unnecessary identity or infrastructure dependencies. The actual official documentation actually makes it clear that customers are responsible for all these layers, right? So this means the quality of the design determines the quality of the outcome. A saying I like to, I've used a lot recently in my work especially is, if you put in rubbish, the output is rubbish as well. Take that as you will. Okay, in my next video, I'm going to break down how to design AVD properly for scale. That includes host pools, networking, identity, and performance considerations. Well, look, if there's a specific design challenge you're dealing with right now, drop it in the comments and I'll build it into one of my future videos. Make sure you hit that subscribe button. Thanks for watching. See you on the next one.